Who's going to be first on the chat? Come on. I don't know why I did that. I realized I'm live on YouTube. It was a terrible idea. Oh, no. Who's going to be first on the chat? Right, let's do view YouTube. Let's take that and go copy. And actually, who's going to be first on the chat? Oh. What was it? Right, let's do view YouTube. I need to stop that. Stop. There we go. And then pop out the chat. Pop out chat. And then close the YouTube window bit. Goodbye. Seems to be working okay. Right. Let's see who's first in. I need to post that on Hangout. And kaboom! Woo! Oh, that's an amazing picture of me. Look at Mr. Duncan looking so cool. So cool. Who's going to be first? Oh, look at that. Winkit's first in the chat. Winkit, by the way, is one of my year 13s. Winkit, do you have nothing else to do other than watch my YouTube videos? Oh, it's amazing. Oh, so funny. New contestant. I know, right? He's one of my best chemists, by the way, guys. Winkit is an amazing chemist. Like, he could probably teach it better than I do. He's that good. It's amazing. Right. Let's go through the homework, guys. I'll share my screen. And then he ambushed us. I'll switch to that. I'll also change my camera over. I am really enjoying having my, there you go, look at that. Wow, looking good. Do blue steel. It's my blue steel. Just like that, there you go. Hang on. Does anyone know the film reference? Who disliked? Oh man, has someone disliked my video already? Oh, come on. So mean. All right, let's switch over. Sorry, I know you guys hate my videos. Just hate my videos. Anyway, moving on. So, disheartened Jack. Yeah. Anyway, let's move on. So today's lesson is lesson 3 in chemical tests. It's a nice short lesson, which is really lovely. And this is the anion testing. Before that, I gave you guys a quick activity to do on cations. This is what we've been doing in the last couple of lessons. So the first one, these were just fill in the blanks. These are very super common for Edexcel in their exams. They give you these tables with observations and they ask you to fill in the gaps. So the first one, so lithium, of course, is red. Tick it if you got it. Boom. Next, orange red is Ca2+. Who forgot their charge? 1 mark. Copper 2+ is blue-green. 1 mark. Tick. Yellow is Na+. Tick. Potassium plus is lilac. Lilac. Tick. My determination. No. And then green is barium 2+. Ooh, hello there. There we go. Six out of 6 guys there. If you got it, tick it. No, Jack. If you put purple, you lose it. Do not accept. Don't accept purple or pink. They don't allow either of those. You have to say lilac. I also said lilac. Okay, good. Next, right, these are a bit more challenging. So we've got no observation on a flame test, a white precipitate with no change on excess. Right, that's got to be magnesium 2+. If it had given no information on the flame test, it would have been magnesium 2+ or calcium 2+. But in this case, it had no observation, so it must be magnesium 2+. Tick it if you got it. Aluminium would have been a white precipitate. I'm going to put PPT just for ease. And then I'm going to put redissolve on excess. 1 mark. Tick. I'm actually going to say you can have 2 marks for that. If you've said a white precipitate, you can have 1 mark. If you've then said redissolve on excess, you can have a second one. That means it's not going to be worth 11. It's going to be out of 12. Observation on the flame color, no change. Just to say, by the way, I discovered a really common mistake that my students were making a couple of years back. Some of the students were putting no observation. Now, if you write that, it means that you did the chemical test wearing a blindfold. You can't say no. It's like, no observation. Yeah, the answer is no change. I don't know what website they got it from, but you can't write down no observation because it literally means like you're adding you're pouring the stuff in blindfolded. You're going to make a mess as well, like a proper mess. Next, a green precipitate goes brown on standing. There's Fe2+. Observation on a flame color would be no change. Next, Cu2+, observation with sodium hydroxide would be a blue precipitate, blue PPT. No change on standing. It would be no change and no change on excess. I'm loving the new webcam. Ah, thanks, Zina. Thanks. Hearts. Blue precipitate, that's all you need. Observation on the flame, that's our blue-green again. Tick, 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 tick. Here we go. Next one, a brown precipitate, no change on standing, no change on excess. So that's going to be iron 3+. You don't actually need to state any of the other observations in those particular ones, which I think is always rather irritating. Observation with flames, no change. If it's not one of your 6, then it's just going to say no change. Yeah, you know your 6. Stick with your 6. Right, orange-red on flame color. Well, that's going to be Ca2+. And then observation, it's going to form a white precipitate. White PPT, no change on excess. No change on excess. I like it. Right, next. So tick. So how many ticks are there? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's out of 12. Boom. Yeah. Next. Right. So these questions are super common for Edexcel. They're basically on every single paper one. They either ask you for the flame test method or alternatively, the sodium hydroxide test method. So it's worthwhile just seeing these bullet points from the mark scheme. So the first thing says is wash nichrome wire in dilute HCl. If you just put HCl, you can have it, but it's worthwhile mentioning that it's meant to be dilute. You actually assume dilute. So that's kind of the point. If you don't include that word, it's fine. If you just said in HCl, that's okay. But it's nice to add that in. I feel like there's some value in it. Next bullet. So that's 1 mark. Next, right, pick up small sample. Pick up small sample. By the way, if you don't write down the word small, you lose it. I know. That's because chemical tests are all done on small scales, tiny scales. Pick up small sample of unknown solid. Next, place in blue or roaring flame, whichever one you fancy. Roaring flame. Yeah, 4th mark, record observations. Now, can I just say, by the way, that I do like to add, those are the 4 marks off that question. Would I get the mark for saying a bit? Julius, yes, you probably would actually. Like the person marking you would probably be like, yeah, okay, he's words to this effect. Can we say results, record observations, record results? That's a good question as well, actually. That's actually way more tricky than Julius's. Julius would have got it because a bit means a small amount. If somebody said, I had a bit of sushi, you're not having loads of it, you're having a small amount of it. Record observations, record results. Sure, I'll give it to you. Yeah, I think they would as well. Record color observations is perfect, Jack. Heck, write that down. That's actually the better answer than mine, Jack. Yeah, but I prefer that. Yours is better, as you're only seeing the colors. Yes, definitely. There is a 5th one that I just want to mention, which is, it wasn't on the mark scheme for this question. If it said, write the method for doing multiple tests, they've only ever done this question once, by the way. I think the reason why they've only done it once is because nobody got the mark. you had to say wash in each test after each test, which was really stupid. So it's something to just to consider. But as I said, those are the 4 marks here, guys. Those are your 4. Tick them if you got them. I wrote observe the flame color. That's absolutely fine. Zina, that's perfect. Absolutely perfect. Keep that. It's better than mine. Next, how do you perform the precipitate? Like this question. I think it was June 2013 or 14. When I did the exam review with my year 11s after they'd done it. They all but 3 lost this mark. So the first thing is take a small sample of unknown, and that is the mark. Take a small sample of unknown and dissolve in distilled water or deionized, whichever one you prefer. I don't care which one you choose. Deionized means we've removed the ions, and dissolve in distilled water. That's 2 marks straight off the bat. Boom, just like that. Now it becomes tricky. So the next one is once you've dissolved, now 3rd mark, add 3 drops. By the way, it actually said on the mark scheme a small amount. I prefer 3 drops. You get it for 3 drops. And I prefer it in the method. It's better. Add 3 drops of sodium hydroxide solution. And I think the word solution there was actually needed on the mark scheme. I actually went and found this question, by the way, when I was making this worksheet, because I wanted to kind of have an idea in my head of those marks that were there and how specific they were wanting. So because you can't add drops of it. You had to say the word solution if you said the word drops. That's what it said on the mark scheme, because sodium hydroxide is a white ionic solid, and so you had to say, it's horrible that. So that was the 3rd mark, right? The 4th mark was horrible because I thought, just like the students did, I thought that the mark would be for record observations. Record observations. But it wasn't. It wasn't the mark. And this was the nightmare. What you had to then say is record observations, and then the 4th mark was actually for saying either leave to stand, and record any changes, or, so these 2 got tied together, or add excess sodium hydroxide solution. I'm just going to put aqueous because it's easier. Yeah, add excess sodium hydroxide and record any changes. It was really mean, record any changes. It was a great question. What a separator that was. So these 3 here were all the 4th mark, but you couldn't have just record observations. That said, do not allow simply record observations for M4. Said you are required to give either add excess or leave to stand. It's the idea of them, what they were doing is they were saying in the mark scheme that for the 4th mark, the students need to understand that there's an extension on this for these ions, that it's not as simple as the flame test, stick it in, record the result. You can't change that result. I need to actually mention one more thing about flame tests, by the way, because when I was in that same paper, that had that, the flame test one was super mean, and I'll mention that in a second. So this is out of 4, boom, out of 4. Next, write an equation for the following precipitate reactions. Write Fe2 plus 2 OH minuses goes to Fe brackets OH2 solid, 1 mark. Calcium doesn't give you a charge because they don't need to, because it's always 2 minus 2 OHs forming Ca brackets OH2 brackets S. Aluminium, they don't need to give you the charge either because aluminium is always 3 plus. This one requires 3 OH minuses, Al brackets OH3 solid. Next, oh, I'm just worried. Someone's like, my phone's just beeped, and I'm worried that they're telling me the sound's bust or something. That seems to be happening quite a lot these days. Oh, okay, no problem, Zina. You go. Have a great day. Good luck. Copper 2, Cu2 plus 2 OH minuses forming Cu brackets OH2, solid. And then iron 3 plus 3 OH minuses goes to Fe brackets OH3, solid. And we're done. 5 marks. Boom, 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 boom. What's the total sheet out of? What was it? So Duncan is so cool. So cool. So we've got 6 plus 12, 18, 22, 26. It's out of 31. Yeah. So my question to you guys is, how many did you get? What I'm going to do, I'm going to ask you guys to add your scores to the score sheet. I'll put the score sheet onto the chat again. I know you guys need it. There you go. So score sheet here. You can add in your results. It's always nice to do it. All the lovely homeworks you've done. Amazing. So this one was out of 31. Out of 31. And this is cation testing. Boom. And then I'll share the link with you guys. Because I know most of you will have lost it. Copy. And then I'll paste it into the... I look so cool right there. Paste. La bast. There we go. I've pasted it onto there. Let's close that one down. I think that's... Oh, no. And go. There we go. So you guys can add your scores to the score sheet. Give it a go. Give it a go. Give it a go. Give it a go. Oh, look at that. Julius, 30. Smashed it. Well done, Julius. Ledge. Good man. Good man. I'm loving it. Amazing. Jack got 22 out of 22 for all the ones he'd done. Yeah, Jack, you need to work on that, trying to finish it. You should have just, Jack, in future, you should just pause the video, finish the bit, and then add it in later, and then you can just watch it afterwards. That's fine. That's fine. I've got 15 minutes to do anion testing. Amazing. Right, I'm going to go back to here, guys, and I only need 15 minutes for anions. Well, for one of them. So, title is anion testing. Anion testing. Anion, a negative ion. A negative ion. Yeah, anion testing. So, the first thing we need to do for anion testing is we need to do the halide ions. The halide ions. Halide ions. So we are now going to be testing for the fluoride, the chloride, the bromide, and the iodide. Let's just put the names next door as well. Fluoride ion, chloride ion. Notice the ides, of course. The bromide ion. Whenever you say bromide or bromin, you've got to say it like an Italian accent with a roll, that bromin. Yeah. So bromide ion and then iodide. The iodide, of course, is evil. So you've got to say it with like an iodide. Yeah, that's the one. So we need to test for these 4 ions. Now, the best thing about the halide ion test is it's all the same. Just like when you're doing the cation test with the solutions, you know, all the metal ions can be detected with sodium hydroxide. Well, with the halide ion test, the great thing is the test is the same as well. So now the first thing we need to point out, the first nota bene, is fluoride. Nota bene. And I'm going to point it directly at him, or in fact, her. We all know that non-metals are females. We all know this. So the fluoride ion, nota bene, cannot be detected. Cannot be detected. Brackets, all fluorides are soluble. What that means is you never get to precipitate. These are also precipitate tests, so they're going to be in test tubes. Yeah, so Now, this is an odd thing. Students often get really confused then why I include this on my lesson. They're like, hang on a sec, sir. If you can't detect fluoride, why are we putting it in the tests? Because it's a negative test result. If someone said to you, I have got a sodium X, and the X is a halide, I'm going to do the tests for the halide, and if I see no result, then I know it's fluoride. Does that make sense? You can make that note if you like. Do test, and if no result, and if no change, stroke no precipitate, PPT, then fluoride. Then fluoride, F minus. Yeah, it's a clever game. They do love that. So, okay, so what's the test then? I shouldn't do that. I don't like doing this where no, I don't like it. You've got to do it. You've got to encompass the fluoride ion because it is the same test. Right. So, method. Step number 1, S1. Take small sample of unknown solid, 1 mark, and add to 1 centimeter cubed of distilled water. It's very reasonable that I'm giving a quantity there. By the way, you can have that same quantity, but you don't actually need the quantity. You can just say add to distilled water. You can just do that. Add to distilled water. But you're only going to add it to a small amount of it, to distilled water, or deionize, whichever one you want. Right, 1 mark. Yeah, oh, it's actually 2 marks, that. 1 mark is for the small sample. Yeah, the other mark is for distilled water. Right, and dissolve. Step 2. Yeah, that will now dissolve. Brackets, dissolve. I like that. Next. Right, now what we need to do is we need to add nitric acid. Add a small amount of dilute nitric acid. You don't need to say the word dilute because it's assumed, but I like to do it. Dilute, and by the way, capitalizing this, guys, nitric acid. Underneath HNO3. Right, so first question is, what's the function of the nitric acid? I'm going to come to that in a minute. You'll see why in a second. Step number 3, add a small amount, add 3 drops, like it, 3 drops of silver nitrate. 3 drops of silver nitrate. I'm going to put brackets AgNO3 aqueous silver nitrate solution. Step 4, record observations. Record observations. Observations. Right. Okay. Let's now explain what we're going to see. So, yow chow. So, what are we going to see? YouTube. I will then explain what the nitric acid function is, because this comes up every year on Edexcel. Halide ion test. Guys, please do, and because we're not in school, we're not doing any real chemistry. You'd be doing all of these things. And I just want you to realize that you can watch these things on YouTube. Like, you can. Let's try this guy because he's got a black background.
Potassium chloride, potassium bromide solution in it.
Yada yada yada, yada yada yada, yada yada yada. Oh.
And we notice that it turns a bit of a darker color than in the case of the chloride. We call it cream colored. And that cream color is silver bromide. And now we add some silver nitrate to the iodide solution.
That was amazing.
And the color turns even darker, yellowish. And
right.
The yellow color is
perfect. So the 3 observations, they're all going to form precipitates. So the observations that we now need. For chloride ions, yeah, you are going to form a white, a white precipitate. Let's do the equation. Ag plus Cl minus goes to AgCl solid, and that is white. Next, underline. Next, bromide. So bromide forms a cream precipitate. So the equation, Ag plus Br minus goes to AgBr solid, and that is a cream solid. Yeah, that's correct, guys. White and cream, what a nightmare. Next, last one is iodide. So the iodide ion will give a yellow precipitate. Yellow PPT. Yeah, of silver iodide. Let's do the equation. Ag plus I minus goes to AgI solid. Solid, and that is yellow. It's a yellow solid. Cool. So that's it. White, cream, yellow. Summary. Now, can I just point out there is a problem here? Cl minus, white PPT. Scared the life out of me. Cream PPT.
Hello.
And an iodide,
Yes.
being a yellow PPT. So, question on the chat, guys. I know I've only got 6 minutes left. Can anyone tell me which of these two is going to be the problem? Which two are going to be the problem? Look at the picture from the video. Hang on, I can find you a better picture. Halide ion test, and then click images. Which two are going to be the problem? Look at that, perfect. No, I don't want you. There we go. Which one's going to be the problem? Which two? BR and I. Really, Julius? Like, look at the picture. Like, really? I'm going to copy that if I can. Copy image. Really? You think that one's... Really? There's only one that really stands out. The one that stands out is the iodide. I don't really... Like, the iodide's like, oh, yeah, it's yellow. Yeah, it stands out a mile. The problem are these two. Because if you didn't have them sitting next to you, Nish animates. I don't know who that is. Hi, Nish. The white and the cream are going to be a problem. Because if they're not next to each other, if you just got a cream formation, you could totally think it's going to be white. So there is a confirmation test. So how do you confirm these now? So here's the confirmation. And I'm actually going to do the confirmation up here. I'm going to see if I can move that down to there. So next thing, to confirm. So by the way, this is, hello, Mr. Hi, Nish. So this, by the way, guys, this is your method if they ask you for the method. And the method ends at this stage. Please don't go any further in a method. What they could do, though, is say, how could you distinguish between the white cream and yellow? And that is a separate test. This here is the confirmation test. And what you do, so number one, I suddenly realized I don't want to put it there. Yeah, to confirm these, I'm going to put confirmation up here. How long have I got? I've got 4 minutes. Confirmation test. So first step is you're going to add to all three, dilute, notice my capitalization, dilute ammonia to all mixtures. Now, when you do this, something really cool happens. The white one will vanish. White PPT redissolves. It vanishes. Yeah? You add a little bit, you splash a dilute ammonia, and the white one, poof, gone. And you'll be like, there's the chloride. Yeah, that's how you distinguish between the white and the cream, is dilute ammonia. What that now means is, let me draw this in the picture. This picture here now becomes this. The white one goes completely colorless and see-through. Yeah, the cream one is still cream. This one is, I need to be careful here on choosing my colors. The cream one will remain cream. Yeah. Remains, nope, that's not how you spell remains. Remains cream, and the yellow remains yellow. And the yellow one remains yellow. And you go, right. So I definitely know that that one that one, and then I need to change it back to, no, go. Is that better, guys? I'm hoping I fixed it. Really hope so. I know, my ears, it's screeching. I know. Is it fixed? Oh no, look at that. Try turning it off and on again. Have I fixed? Yes, there. Sorry. Technical difficulties. So the next one is add concentrated ammonia to the last two. Add concentrated ammonia to cream and yellow. Cream and yellow mixtures, and the cream will vanish. Cream redissolves. And you're done. That's it. 1 minute to go. So now cream remains, yellow remains. Yeah, yellow remains at this point. Yellow, cream remains cream, remains yellow, yellow remains. Oh no. And then we go add conc ammonia, NH3. Yeah. My ears are bleeding. Conc ammonia, and the yellow, and the cream now vanishes. Colorless. Clear. And the yellow will remain. And we're done. The yellow will never vanish. Isn't that clever? We will be doing all of these in class as soon as we're back in school, I promise. I love this game. There's such great games. And that brings me to the end of my lesson. How lovely is that? Oof, oof. Observate for the nitric acid. Anything for 400 subs. Idea is a real life experiment. Nish, as soon as I'm allowed in school, I will do all of these on YouTube, promise. Right, guys, I know I'm overshot by 1 minute. You guys can leave now. I'm just adding one more thing. Nota bene. A big fat nota bene as well. Sorry, and go to your next class, guys. It's fine. Nitric acid. Nitric acid is used to remove any carbonate ions. Carbonate ions. Now, the reason why, just to explain why, the reason being is carbon dioxide in the atmosphere. I've suddenly realized it's not showing. Carbon dioxide in the atmosphere dissolves into the carbon dioxide in the atmosphere dissolves into water. So if I have a beaker and it has water in it, the carbon dioxide in the air will dissolve into the water, and the carbon dioxide will react with water to form carbonate ions. So they get everywhere. It forms. It actually forms 2 H pluses and 2 carbonate ions. Sorry, and 1 carbonate ion. It forms this guy. Now, the carbonate ion is a massive problem. The reason being is, that's why the oceans are becoming acidic, by the way. The problem is silver 1+ ions will also react with carbonate ions, and they will form silver carbonate. and silver carbonate is a white solid. And guess who we think it is? We think it's a chloride. So you've got to destroy it before we do it. He's only 8 subs away. I hope that helps. I'm sorry for the rush of nitric acid there at the end, guys. I will leave you guys be. Go and have a lovely last lesson, and I will see you guys soon. See you later, guys. Nice to see you, Nish. See you later, guys. I will leave you all be.